do I want to make methanol? Well, you could make methanol because you could put it directly in fuel cell. Once we completely discover fuel cell that use methanol. Also, we could blend it into gasoline. We could use it what? In H2CO. We could also blend it into make acetic acid, because that's the next step. Once you make methanol, then you got to go through another process with NH3 to produce acetic acid. So from here, we could make acetic acid, also blend it in biodiesel and make what? DME, dimethyl ether. Okay. So here we see methanol could use for several different things. However, to get there is not as easy as I first thought. Okay, it's not as easy as I first thought. The first step here is what we call the carbon-hydrogen oxidation across the metal methoxy bond. What do I mean by that? Now you have the methoxy system here, right? This is the methoxy system. You got to bring in a methane. Once you bring in the methane, you got to do the CH activation. And from here, from the CH activation, you can get several different avenues, several different pathways you can go through to do CH activation. You can do CH activation, what we call sigma bond metathesis. That's one reaction mechanistic vehicle one could use. You could also use another mechanistic vehicle, which is called what? Oxidative hydrogen migration. Now, both of these two systems are relatively similar. The difference between the sigma bond metathesis and that of the oxidative hydrogen migration is the distance that the hydrogen that's migrating is from the metal center. That distance, which I'm going to point out in a second. That distance. From there, what you do, what we call a two-step process, you oxidize the complex, and then what? You reduce it, which is called oxidative hydrogen migration, or oxidative addition reduction elimination. So you could oxidize the metal system, and then you reduce the metal system. The drawback to this system right here, you have to use, where's our periodic table? No periodic table. The drawback to this particular system, you have to use what? Late transition metal, right? You have to use late transition metal like platinum, iridium, rhodium. These systems are very expensive, and why? Because platinum mimics that of carbon, right, for electronegativity. And when you oxidize a system, what you're doing, you're pulling some of the electrons away. Therefore, you're reducing the electron count in that complex. So you need high electron count systems. You can't use early transition metal. You have to use late transition metal for the system. Then you could do what we call BAD. This is a system that I've coined. It's out there in literature right now. It's called basic system protonation. We call it BAD, where basically what we're doing here, this proton is out here. So this is the electron. This is nucleophilic. This is the nucleophilic system. This is the electrophilic system. So basically, this nucleophilic system is pulling off this proton from off of this system. So we call it BAD. Another one is CMV, which stands for concerted metallation deprotonation. This system mainly works with benzene system, aromatic system. It doesn't work so much for that of an alkene system like what we're trying to do. And the last one is the hydrogen atom extraction. See, so there are several different mechanistic vehicles one could use to do CH activation. So CH activation is not a pie in the sky idea. It's been around for the last 50 years. It's been around for a while. Okay? Now, and then the last one is the sigma plus 2, which if you're going to use a system, you need what? An olefin system. Okay, you need a diene system. And a dienophile, you need a diene system, an olefin system. Now, after you're producing methanol, the goal here now is to store it, right? So you got to dissociate it off of the complex. Once you dissociate it off of the complex, you send it downstream and you store it in some type of tank, some type of storage vessel that you do have. The last part of the catalysis cycle is one of the most difficult processes, where you're going to take an oxygen transfer, which is called OAT, oxygen atom transfer, and with the newly formed metal group bond, and insert the oxygen between these two systems. Okay? You're going to insert the oxygen. Now, how do you do that? You do that by having that methyl group migrate off of that of the metal center onto that distilled oxygen. Okay? Now, that is more difficult than it sounds. And why is that? Because carbon, its orbital is what? We call it what? Dumbbell shaped. It's not spherical. So it only orientate in one direction. You orientate in this direction, or in this direction, or in this direction.